All right, so in this lesson, we're going to be covering the very first lesson of algebra. So this is going to be about combining like terms in the distributive property. So just kind of looking up here, so we have some terms and some definitions for you to kind of read over and look over. So like terms are mathematical terms that have the exact same variables and exponents. However, the coefficients, the numbers in the very front can be different. So distributive property is going to be covering an algebraic method that we're going to be looking at here. So an expression is essentially just a mathematical sentence. It just has a minimum of two numbers and at least one mathematical operation. So one thing to really look at here is an expression does not have an equal sign. An equation has an equal sign, whereas an expression does not. So we're going to be looking at simplifying these as well. So simplifying is just a very fancy way of saying I want to condense or write it in fewer terms. So an operation is just adding, subtracting, multiplying, dividing, any of those. So then we have what we call descending order, which we're going to cover in greater detail later on. But descending order is just an order in which we write our expressions. So for descending order, we want to write an expression from the highest degree to the lowest degree. So what that essentially means is we want to write it from the highest exponent to the lowest. So we'll cover that more in detail in a little bit. So just starting off, so we're going to look at the distributive property. So for the distributive property, you're going to have some value outside a set of parentheses. So in this case, we have a value a that is outside the parentheses. So when I say distribute, I want to take that a value and I want to distribute it to every term inside the parentheses. So when I distribute, you're going to be multiplying. So I want to do a times b, which gives me the first term. And then for my second term, then I'm going to have a times c. So I'm giving a to both of those values. So I have ac. So because that value is positive, it's going to be addition. So over here, same idea. I have a outside of the parentheses that I want to distribute it to everything inside the parentheses. So I have this a value, and it's going to be distributed to b and to c. So in this case, just like before, we have a times b, which gives you ab. And now we have a times c here. However, the c here is being subtracted, so it's negative. So I have a times a negative c, which is going to give us negative ac. So in this case, we're actually going to be subtracting. So we're going to be using that idea to help simplify a lot of these problems. So over here, for the very first one, we have 2 times x plus 4. So I am distributing this 2 that's on the outside of the parentheses. So I'm going to distribute it to x, and I'm going to distribute it to 4. So remember, when you're distributing, you're going to multiply. So this is going to be equal to 2 times x and 2 times 4, which gives you a positive 8. So 2 times 4. So our simplified expression here is going to be 2x plus 8. Looking over here at the next one. So this one's a little bit different. So in this case, we have a 4 on the outside of the parentheses. However, instead of it being on the left side, it's on the right side. So just because it's on the right side, it doesn't really change up the problem too much. It just means we're distributing something that's on the right side. So you're not going to see this too often, but every now and then you will. So I'm still distributing that 4. So it's still the same rules as before. So I'm going to multiply 4 times m, which gives us 4m. And now I'm going to multiply 4 times negative 3. So 4 times negative 3 gives me a negative 12. So we're going to have 4m minus 12. That's our simplified expression. All right, so for number 3, this one's a little bit more tricky, all because of this x right here. So we're still distributing, but now we're distributing a negative 3x. So I'm actually going to write this out in a few different steps. So you have negative 3x times x, and then here we also have a negative times a negative. So when you multiply those, you're going to get a positive. So I have 3x times 1. So anything times 1 is just that value itself, so we don't actually have to write that one. So now I'm going to clean it up a little bit. So negative 3x times x. So whenever you're multiplying two variables together like this, the exponent is what's going to change. So I have negative 3x squared plus 3x. So this squared is going to come from writing this x twice. If I wrote it 3 times, it would be to the 3rd power, or cubed. If I wrote it 4 times, it'd be to the 4th power. If I wrote it 5 times, to the 5th power, so on and so on. So in this case, this would be our simplified expression right here. So just to kind of write it out for you, so if I have x times x, that would be x squared. If I have x times x times x, that would be x cubed. If I have x times x times x times x, that would be x to the 4th, and so on and so on. All right, number 4. All right, so now in this case, we're distributing a fraction. So since we're distributing 1/3, this is the exact same as dividing by 3. So if I was doing 1/2, then I would divide by 2. If I was distributing, say, 1/4, divide by 4. If I was distributing 1/6, divide by 6, so on and so on. So in this case, I'm going to distribute that 1/3, which means divide by 3, to everything inside the parentheses. So in this case, we have 3 different terms that we have to distribute it to. So I'm going to have 24 divided by 3. That gives you 8x. Now I have 18 divided by 3, which gives you 6y. Now I have negative 3 divided by 3, which gives you negative 1xy. Now in this case, that 1 right there, we don't have to write that 1. You can if you want to, but on assessments or anything like that, you will not see that 1 written. So 8x plus 6y minus xy. This would be your simplified expression. All right, so now I would suggest right here you actually pause and actually try these on your own. Okay, so let's take a look at number 5. So just like before, this 4 on the outside, you're going to distribute to both x and to 2. So 4 times x gives you 4x. 4 times 2 gives you 8. So this is our simplified expression. All right, number 6, this one's a little bit different. So I did this one on purpose so you could actually see a bit of a difference. So in this case, we're going to be distributing a negative 5. So one thing I want to kind of make you notice is how it's written in parentheses here. And then I want you to kind of think about this question over here. So how is g plus 2 minus 5 different than what's written over here? Okay, so I'm going to kind of let you think about that for a second. But in the meantime, so we're going to distribute negative 5. So negative 5 times g gives you negative 5g. Negative 5 times positive 2 gives you negative 10. So this is our simplified expression. All right, so over here, now looking at this question, so the reason this is different is because it doesn't have those parentheses. So the parentheses over here tell you to distribute the negative 5, so it's actually being multiplied. However, over here, this is actually just subtraction. So this is actually g plus 2 minus 5. So this could be rewritten as g plus 2 minus 5. So if I were to simplify this, you would have g and then 2 minus 5, which gives you negative 3. So those are different. So be very cautious about those parentheses. All right, number 7. So 2n is on the outside, so this is what we're distributing. So 2n times n and 2n times -8. So I'm going to expand this one. So I'm going to have 2n times n, then minus 8 times 2 gives you that -16. Got to account for that negative. And I'm going to throw the n right on the end. So I have n times n, so I'm going to rewrite that as 2n squared minus 16n. All right, number 8. So this is where kind of the honors extension is going to come into play. So for on level, you may see some problems like this, but not as often. Honors, you're going to see a good amount of problems like this, where you're going to be dealing with fractions. So now we're going to be distributing the 3/4. So I'm going to write it out step by step. So 3/4 times 12c minus 3/4 times 1/2 times h. All right, so whenever you're dealing with these fractions and whole numbers, what you want to do here is you're going to multiply the numerator times the whole number on the side. So 3 times 12 gives you 36 over 4c. And now I want to multiply 3/4 times 1/2. So to multiply fractions, multiply across. So we're going to do 3 times 1 and 4 times 2, which is going to give you -3 over 8h. So you just want to keep simplifying. So we have 36 over 4, which can simplify. So we have 9c minus 3/8h. So can't combine anything else. Everything's simplified. So this is our simplified expression for this one. All right, so now we're going to kind of introduce combining like terms and descending order. So this is really focusing on just the distributive property. So when I say combining like terms, we're looking at values that have the same base and the same exponent. So this can be rewritten into fewer terms using addition and or subtraction. So this is what we're really going to be focusing on here, addition and subtraction. So all of these values, when we're combining like terms, should be written in what we call descending order. So descending order is when we're looking at our values and we want to write it from the highest to the lowest. So for example, if I have a to the 4th minus b squared minus c cubed plus d to the 4th power, so we're looking at those exponents. We want to look at which ones have the highest exponents and write those first. So notice how a and d both have an exponent of 4. So to determine which one you write first, you just go in alphabetical order. So a comes before d, so I'm going to write that one first. So a to the 4th, done, plus d to the 4th, done. So now we want to go from highest to lowest. So now the next value that we have is 3. So we have a negative c cubed. So I'm going to write minus c cubed. So that one's done. And then last but not least, we have a negative b squared, which matches exactly what's over there. So we're going to be using that kind of logic when we're doing these next problems. So now these are just going to be about combining like terms. So we're also going to bring in the distributive property as well. So looking at number 9, we just want to simplify using combining like terms. So we're just looking to see what has the same base and what has the same exponent. So when I say base and exponent, so let's say I have a raised to the b. So this a value would be the base, and the b value would be your exponent. So for example, let's say we have 3 raised to the 5th. 3 is the base, 5 is the exponent. If I have x raised to the 6th, x is the base, 6 is the exponent. So if I have y to the pi, who knows? Y is your base, pi is your exponent. Okay. So looking at number 9, we want to be able to combine like terms. So more specifically, I have an x here. I also have an x here, and I have an x here. So none of these have a squared or a cubed or anything, so they don't have an exponent. So you assume the exponent's actually a 1. So the bases are the same and the exponents are the same. So I'm going to combine all those x's into 1. And then if you look at the y's, we have y to the first, y to the first. I'm going to combine those. So the numbers that are different, so the 3, the 4, the 5, those are what we call coefficients. Those are what we're going to use to combine. So I have 3 plus 4. 3 plus 4 gives you 7. 7 minus 5 gives you 2. So I have 2 x's. And if I have a negative y, well, there's no number in the front. So if there's no number in the front, you assume there is a 1. So this is a negative 1. So I have a negative 1 and a negative 9. So if I combine those together, negative 1 minus 9, that gives you negative 10. So I have 2x minus 10y. So this would be simplified. So number 10. So now we're going to start bringing back the distributive property. So you always have to get rid of anything in parentheses first. So meaning here, you have to do the distributive property before you can combine like terms. So you only distribute to what's inside the parentheses. Notice how this plus r squared here, that's not inside the parentheses, so it doesn't get that negative 2r. Same thing with the 6r out in the front. That's not inside the parentheses, so it doesn't get that value. So because I'm only distributing first, I'm not going to change that 6r. It's going to stay the same. But when I distribute, so negative 2r times r, and then I have negative 2 times 4, so negative 8r plus r squared. So I'm going to simplify a little bit more. So remember, if I have r times r, it's being multiplied by itself 2 times, which means it's going to be squared. So I'm going to have 6r minus 2r squared minus 8r plus r squared. So now we want to combine any like terms that we can. So you want to look at the base and look at the exponent. So if you notice, we have an r and we have an r squared. So here's the thing, the bases are the same, but here the exponent would be a 1, but the exponent over here is a 2. Those are not the same, therefore we cannot combine those. So what can be combined is 6r and negative 8r. Their bases are r and their exponents are the same, which is 1. So if I look at my other values, I have negative 2r squared and r squared. The bases are the same, and the exponents are the same, which is 2. So in this case, I'm going to have 6r minus 8r, so 6 minus 8, which gives you negative 2r. So the coefficient's what changes here. The actual variable here, it stays the same. So now I'm looking at the squareds. So negative 2r squared plus r squared. So this is a 1, since there's not a value written. So negative 2 plus 1, which gives you a negative r squared. So we actually have one more step on this one. So look at the order. It's not in descending order, so I need to rearrange it. So we have a higher exponent of 2 as opposed to this 1 that's over here, right there. So I'm going to rewrite it as negative r squared minus 2r. This is what you would look for. All right, number 11. All right, so we do have some parentheses. So here's the thing, there's no value that's written here. So just like before, if there's no number written, you assume there is a 1. So in this case, we're actually going to be distributing a negative 1. So I'm going to distribute. So the 15t is staying the same, so I have 15t. Then minus t plus 4. plus 8x. So just a little side note, I write my t's with a little curve at the end, just so you don't confuse them with a plus sign. I recommend you put a little curve on the end too, but it's up to you. Just make sure you don't get your t's and your plus signs mixed up. All right, so now I want to start combining like terms. So I have a t here and a t here. Those exponents are the same, the bases are the same. I can combine those. However, if you look here, neither of those terms have anything I can combine it with. So if I try to combine t and x, the exponents are the same, they're all 1. However, the bases are not the same, so you cannot combine those. So in this case, our simplified expression, we have 15t minus 1t, which gives us 14t, plus 4, plus 8x. So there's still one other thing we got to do. We have to rewrite it in descending order. So that means I need to put everything with a variable at the front, and any just natural standalone numbers, those go to the very end. So essentially what I'm doing here is I'm just switching the 4 and the 8x. So I have 14t plus 8x plus 4. All right, number 12. This one's going to be a bit lengthy just because of how much it requires. All right, so we have two values in this case that we have to distribute. So we're going to distribute this 2/3 to everything in the first set of parentheses. Then in the second set of parentheses, we're actually distributing a negative 3/4. So to start off, 2/3 times g. So we have 2/3 g plus, now you're going to multiply 2/3 times 1/2. So 2/3 times 1/2 f. All right, then the next set, negative 3/4 times 8f. And then negative 3/4 times g, which just gives you a negative 3/4 g. All right, so we're going to start simplifying. So the 2/3 g in the very front is good to go. So I'm going to multiply the 2/3 times 1/2. So remember, I'm going to multiply across. So the numerators get multiplied and the denominators get multiplied. So 2 times 1 gives you 2. 3 times 2 gives you 6, f. All right, and then just like before, I'm going to multiply the numerator times the whole number. So 3 times 8 gives you 24 over 4 minus 3/4 g. Now I'm going to simplify these fractions. So the 2/3 is already simplified, so I'm going to leave it alone. Now 2/6, that can simplify to 1/3 f. Then 24 over 4, oops, forgot my f up here. So 24 over 4, that simplifies, will give you negative 6f minus 3/4 g. So now we want to start combining our like terms. So our g's can combine, and then our f's can combine. So in this case, we want to be able to combine 2/3 and 3/4, and then we want to combine 1/3 and negative 6. So in order to do that, you have to get a common denominator. So between 3 and 4, to find a common denominator, you can just multiply them together. So 3 times 4 gives you 12. So I'm going to have a common denominator of 12. So for the first one, to go from 3 to 12, you multiply by 4. So I'm going to multiply the 2 times 4, which gives you 8. So that's the first one, so g. And now I'm going to go ahead and bring the other g term up here in the front. So now I'm going to look at this term right here. So 4 times 3 gives you 12. So I need to multiply everything by 3. So 3 times 3 gives you 9. All right, so that's for the g's. Now I want to look at the f values. So over here, we have 1 over 3, and we have 6. So 6 is actually rewritten as just 6 over 1. So we have a denominator value of 1. So if I want the denominator value to be 3, then I'm going to multiply everything by 3. So that means that 1/3 is going to stay the same. So 1/3 f. And now I want to change that 6 to match a denominator of 3. So I'm going to do 6 times 3, which gives you 18. So 18f. Now I can start combining. So you just look at the numerators, but you keep the denominator the same. So I'm going to have 8 minus 9, which gives you a negative 1 over 12. Keep the denominator the same. And then over here, now we have 1 minus 18. So 1 minus 18 gives you negative 17 over 3f. So this would be our simplified expression here. So that one's a lot more involved, but still doable. Okay, so suggest you pause here and actually try these 6 problems on your own. Okay, so I'm going to kind of go through these a little bit quicker. So 3c minus 4c plus 6k plus 3k times k minus c. So you have to distribute first. So there's not a number out in the front here. So you have to distribute a negative 1. So negative 1 times 4c, negative 1 times 6k, and 3k times k, 3k times negative c. So I'm going to have 3c minus 4c minus 6k plus 3k squared minus 3kc. So now we can look to see what we can combine. So in this case, we have 3c and negative 4c. However, nothing else can be combined. So because of this k right here, we can't combine it with that negative 3. Because this is k squared, can't combine those. So the only thing we can combine is just c's. So when I do 3 minus 4, you get negative 1c minus 6k plus 3k squared minus 3kc. Now we want to be able to write these in descending order. So you want to look at the highest degree first. So we have 3k squared here. All right, now see here, we actually have 2 variables. So that's actually a degree of 2. So I have negative 3kc. Then we have negative 1c and a negative 6k. So once again, they have the same exponent value, so just write them in alphabetical order. So I'm going to write minus c, we don't need the 1, then minus 6k. All right, number 14. So I did this one on purpose. Is there anything to distribute? Nope. Is there anything to combine? No. So what is there to do? Well, in this case, all we can do is just rewrite it in descending order. So we have to write the highest degree to the lowest degree. So we write 5x squared first, plus x minus 4. So it just has to be reordered. That's it. All right, number 15. All right, so in this case, a lot of this is just about reordering and combining. So let's see what we can combine. So a negative 5x, we don't have any other x's anywhere, so can't combine anything. 4x cubed, well, we have 4x cubed here, and we have a negative 8x cubed here, so those can be combined. So a negative 12, we don't have any just regular numbers, so that cannot be combined with anything. Then we have 7x to the 4th and negative 5x to the fourth. Those can be combined as well. So we don't have any other xy's, so we just combine what we have and rewrite it in descending order. So I'm going to combine first, so just negative 5x. So 4x cubed minus 8x cubed. So 4 minus 8 gives you a negative 4x cubed, then minus 12. So now I'm going to combine my x to the fourths. So we have 7 minus 5, which gives us positive 2, x to the fourth. And then we have that negative xy. So now we just rewrite in descending order. So our highest degree goes first. So we have a degree of 4, so 2x to the fourth. So that's our first term. So count down, so we have a value of 3, so that term goes next. So now you're probably wondering, do we have a degree of 2? Actually, we do. Right here. Because they have a degree of 1 and 1 here, they combine, so we actually have a degree of 2 here. So that's your next term. So that one's done. And then we have negative 5x and negative 12. So because of this variable here, that's the next term. And then negative 12. All right, number 16. So this one's a little bit more mind-boggling. So this one's just about combining like terms again. So we have xy's and we have some xy's. So those can be combined. Now you want to look to see if you have any other x squared y's. So we do have another x squared y, which is over here. Now if you look here, this is xy squared. So the squared's in the wrong place. So if the squared was over here instead of there, then we can combine those. But the 2's in the wrong place, so we can't combine those. So there's no other xy squareds, and there's no z values, so those are just standalones. So we have xy in the very front, so there's a 1 in the very front. So xy plus 3xy, so 1 plus 3, that gives us 4xy. And now we have negative x squared y and 5x squared y. So we have a negative 1 and a positive 5. So negative 1 plus 5 gives you a positive 4 x squared y. So these are done, and these are done. So you can cross them off as you rewrite them if you want, because some of these might get a little lengthy, so you want to keep track of which ones you have left. All right, so next, now we just have the standalone ones. So the xy squared and the negative z, we didn't do anything to those, so you can just rewrite them. So plus xy squared minus z. So I write a slash through my z's just because my z's can look like 2's if I don't. So just another small alteration to your handwriting you may have to do. All right, 17. So in this case, we have a negative 1 that we have to distribute. So I didn't change the very first expression at all, so I'm going to leave it just how it is. So 4n squared plus 3. However, when I distribute that negative 1, all it does is it just switches the signs. So anything that's positive becomes negative, anything that's negative becomes positive. So that positive n squared is now going to be a negative n squared, and that negative 4 is now going to be a positive 4. So now we just got to combine our like terms. So we have 4n squared and negative n squared. So 4 minus 1 gives us 3n squared. And then we have 3 plus 4, which gives us positive 7. All right, number 18. This one's the same idea. It's just a little bit more intuitive. So negative 1, distribute. Didn't change the first one at all. So just switch the signs since we're distributing a negative. So negative 3t squared plus t plus 8. Now we're combining like terms. So we can combine the 4t squared, negative 3t squared. So that gives us a 1t squared. So now we have negative 3t and positive t. So negative 3 plus 1 gives us a negative 2t. Then last but not least, 5 and 8 combined to give us 13. So remember, we can't combine the t squared and the negative 2t because those exponents are not the same. Both the base and the exponent have to be the same in order to combine. Okay, so now we're going to get into some applications. So these application problems are dealing with perimeter and area. So we want to write the expression for both the perimeter and the area of each of these shapes. So if you recall, the perimeter of a rectangle is 2 times the length plus 2 times the width. So I recommend you write a cursive L so that your L's don't look like ones. Or another alteration I've seen is capital L. Just make sure your L's do not look like ones. And then your area is going to be your length times your width. So it doesn't really matter which one you say is which. I'm just going to say this top one is my length. I'm going to say this bottom one is my width. So I'm going to take both of those values and just plug them into their respective place. So for the perimeter, I'm going to do 2 times 3x plus 2 times my width, which is 4. So my perimeter, so I'm going to multiply the 2 and the 3 together. So I get 6x plus then 2 times 4, which gives you 8. So my perimeter here is going to be 6x plus 8. So I'm going to write that in parentheses because it's more than one term. And then you want to include the units. So in this case, we're dealing with inches. So now I need to find the area. So our area here, so we're going to do 3x times 4. So you just got to multiply the 3 times the 4, so 3 times 4, which gives you 12. And then write the x on the end. So our area here, so this is just one term, so we don't have to include the parentheses. So this would be 12x square inches. So inches goes to perimeter, square inches goes to area. So now let's look at the triangle over here. So notice how this one doesn't have any units. So that's going to change your answer a smidge. So we're going to do the perimeter first. So the perimeter for a triangle, you just add up all the sides. So I'm going to have 8h plus 5h plus 4. If you combine like terms, you get 8h plus 5h, which gives you 13h plus 4. So we have 13h plus 4. So that's more than one term. So our perimeter here, 13h plus 4. Now our units in this case, because they don't give us units, your units are just units. All right, so now we're going to do our area. So the area is 1/2 times the base times the height. So we're going to be looking at our base and our height. So we don't really care about this like length. So in this case, we're going to have area equals 1/2 times the base, which is 4. That's not a 4. Times the height, which is 5h. Now I just want to multiply everything together and simplify. So you have a couple different options. So you could multiply 1/2 times 4 first, and then by 5, or you could do 4 times 5 and then multiply by 1/2. It's really up to you. So I'm just going to do 1/2 times 4. So half of 4 is 2 times 5h, and then 2 times 5 is 10h. So once again, because this is area, so 10h units squared.